Hello everyone, welcome back to my YouTube channel. In previous video we discussed about real numbers in detail. Today we will be discussing more about rational numbers. So let us start. What is rational number? So a rational number can be defined as any number which can be represented in the form of p upon q, that is numerator upon denominator, or you can say in the form of fraction where denominator is not equal to 0. When the rational number is divided, the result will be in decimal form, which may be either terminating or repeating decimal. We'll discuss further in this video what is terminating and repeating decimal. The set of rational numbers. It includes positive numbers, negative numbers and zero as well as fractions. So here is a set of real numbers. Natural numbers which are denoted by capital N, whole numbers denoted by capital W, integers denoted by capital Z, and rational numbers are denoted by capital Q. All these four sets are subset of real numbers. So, and integer, whole number and natural number are subset of real or rational numbers. Let us discuss now the arithmetic operation. Basically, there are four arithmetic operations: addition, subtraction, multiplication and division. Let us discuss about addition and subtraction first. When we add two fractions, suppose p upon q and s upon t, these are two fractions. We just need to make the denominator same. So for making the denominator same, we just cross multiply the fractions. Like p upon q plus s upon t, we'll write p into t plus q into s upon q into t. Similarly, for subtraction, we make the denominator same and just the addition symbol is replaced with subtraction symbol. Let us take an example. Now we have to add 5 upon 3 and 6 upon 2. So the procedure will be 5 upon 3 plus 6 upon 2. As you can see, the denominator here is 3 and the second fraction denominator is 2. We have to make both the denominators same. So we'll just multiply the first fraction with 2 and the second fraction with 3. So 5 into 2 upon 3 into 2 plus 6 into 3 upon 2 into 3. Now you can see that both the fraction denominator has become same, that is 6. So 10 upon 6 plus 18 upon 6. Now since the denominator has become same, we can add the numerator as it is. So 10 plus 18 will give 28 divided by 6. Further, if we simplify, we'll get it 14 upon 3. Another example of subtraction. We have to subtract 4 upon 3 and 2 upon 4. So 4 upon 3 minus 2 upon 4. Here the denominators are not same. First fraction denominator is 3 and second fraction denominator is 4. So we just need to multiply the first fraction with 4 and second fraction with 3 in order to make the denominator equal. So 4 4s are 16, 3 4s are 12 minus 2 3s are 6, 4 3s are 12. Now the denominators have become equal, so we can just subtract the numerators. So 16 minus 6 will give 10 divided by 12, and upon simplifying we get 5 upon 6. So this is how we add and subtract two fractions, fractional number, rational numbers. Let us discuss another arithmetic operation, that is multiplication and division. In case of multiplication, when we multiply two rational numbers, we multiply the numerators and denominators of both rational numbers respectively. If p upon q is multiplied with s upon t, we multiply the numerators and denominators respectively, that is p into s upon q into t. Numerator of first fraction and second fraction is multiplied, divided by denominator of first fraction and second fraction. For division, if p upon q is divided with s upon t, then it is represented as p upon q divided by s upon t. Now here, when we are dividing the second fraction which is there, now in this case it is s upon t, we take the reciprocal of that fraction, and when we take the reciprocal, we change the sign from division sign to multiplication sign. Like here, s upon t, the reciprocal is t upon s. So we will write it t upon s, and we'll change the division sign into multiplication sign. So p upon q multiplied by t upon s. Then we'll multiply the numerators and denominators respectively. Let us understand this with an example. We need to multiply 9 upon 4 and 3 upon 5. So just we need to multiply the numerators and denominators. So 9 is the numerator of first fraction, 3 is the numerator of second fraction. Multiply, we get 27. Similarly, we have to multiply the denominators. 4 into 5 is 20. So this is your final answer. Now we have to divide 3 upon 4 by 5 upon 3. Now here 3 upon 4 is divided with 5 upon 3. Now the second fraction is 5 upon 3. We need to take the reciprocal of 5 upon 3. Reciprocal just to the inverse, that is 3 upon 5. So 3 upon 4 divided by 5 upon 3, 3 upon 4, and we took the reciprocal of 5 upon 3, that is 3 upon 5. And we just change the division sign into multiplication sign. And now we have to apply the multiplication rule, that is multiply numerators and denominators respectively. 3 into 3 will give 9, 4 into 5 will give 20. So this is the answer. Next is multiplicative inverse. As the rational number represented in the form p upon q, which is a fraction, multiplicative inverse of rational number is nothing but the reciprocal of given fraction, that is q upon p. For example, if my fraction is 4 upon 3, my multiplicative inverse will be 3 upon 4. Okay, so let us discuss the properties of rational numbers. The results are always a rational number if we multiply, add or subtract any two rational numbers. For example, when we add 2 upon 3 plus 3 upon 2, then whatever result we get, that is also a rational number. When we multiply two rational numbers, the result we get, that is also a rational number. A rational number remains the same if we divide or multiply both numerator and denominator with same factor. Let us understand this with an example. So for example, I have a rational number 5 upon 3. It is said that when we multiply or divide both numerator and denominator with same factor, let us say I have multiplied numerator with 2. I have also multiplied denominator with 2. So my result becomes 10 upon 6. And if I simplify this, again this will become 5 upon 3. So the property says that even if you multiply the numerator and denominator with same factor, the rational number remains the same. Even if you divide it, it also remains the same. Next is, if we add 0 to a rational number, then we will get the same number itself, right? If we add 2 upon 3 plus 0, so we are getting the result as 2 upon 3 only. 5 upon 3 plus 0, 5 upon 3. Let us discuss the decimal form of rational numbers. Since rational numbers are fraction, we can write them in the form of decimal. For example, we can write 1 by 2 as 0.5. 0.5 is nothing, it is a decimal form of rational number. So there are basically 4 types in decimal form: terminating, non-terminating, repeating and non-repeating. Let us discuss the first type, that is terminating type. A terminating decimal is a decimal that has an end digit. It is a decimal which has a finite number of digits or terms. For example, 1.15. Now after decimal there are only 2 digits. So there are finite number of digits. 0.67. After decimal there are only 2 digits. Whereas in non-terminating type, it has infinite number of terms. As you can see, 0.67777. Now the digits are not ending, they are not finite. That 7 is repeating throughout. 1.232323, and that 23 is repeating throughout. It has no end. The numbers are infinite. They are included in non-terminating type. Another type is repeating and non-repeating type. Repeating decimals are the one which has set of terms in decimal to be repeated uniformly. For example, 0.3333. Now here you can see 3 is repeated throughout. There are infinite numbers, but only one digit is repeating. That's why this comes under repeating type. 1.434343. Now you can see the two digits 434343, they are repeating throughout. It is to be noted that the repeated term in the decimal is represented by a bar on the top of the repeated part. Now if I want to write this number like 1.434343, now since 43 is repeating throughout, I can simply write it as 1.43 and I will put a bar on both the digits. This indicates that 43 is repeating throughout. Similarly 0.3 I can write as 0.3 bar, and if one digit is repeating, we even put it as 0.3 and a dot. So this is a representation how we do to indicate that the digits are repeating. Non-repeating decimals are that one that does not have repeated terms. For example, 2.14287023 and so on. Now as you can see, after decimal there are no digits which are repeating in a particular sequence. So that's why these comes under non-repeating decimal. Now when we talk about rational numbers includes three types. First is terminating type, second is non-terminating. In that there are two types, repeating and non-repeating. So in rational numbers we include repeating type, and non-repeating are included in irrational numbers. Now we have to classify the following numbers, the following fractions into terminating or non-terminating recurring type. First one is 13 upon 5. Now first we need to convert this fraction into decimal form, and then we will classify it. To convert this fraction into decimal form, we will just use simple division method. We have to divide 13 by 5. 5 2s are 10, 3 is the remainder. We will take a decimal point 0. 5 6 are 30 and the remainder is 0. Now you can see that the answer is 2.6. After decimal there is one digit, a finite number of digits. The 6 is not repeating, right? So this comes under terminating type. Next 11 upon 6. We have to divide 11 by 6. 6 ones are 6, 5, put a decimal, 6 8s are 48, 20, 6 3s are 18, again 20, 6 3s are 18, again 20. Now this sequence will be repeating. Again I will put 6 3s are 18, again the remainder will be 2, 20, 6 3s are 18, like this. So this here the answer will be 1.833333. Now that 3 will be repeating throughout. So we will write it as 1.83 dot, or you can write 1.83 bar. The number which is repeating, only above that number will put a bar. So this comes under non-terminating recurring type. Now we have to express decimal into fraction form. Previously we done fraction into decimal form and classified into terminating, non-terminating. Here we have given a decimal and we have to express it into fraction form. So there are some steps to express this. Let us understand that steps. Now the first example is 0.666, and here you can see the digit 6 is recurring. So I am assuming let the digit or let the number be x. So x is equal to 0.666, or I can write as 0.6 bar or 0.6 dot. Let be this equation 1. Now the rule is that after decimal, how many digits are repeating, that we have to count. Now in this case there is only one digit repeating. If there is one digit repeating, we'll multiply it by 10. If there are two digits repeating, we'll multiply it by 100. 3 digits repeating, will multiply it by 1000. Now after multiplying both sides by 10, both sides means this is my left hand side is equal to right hand side. So to multiply it by 10, 10 into x will give you 10x. 0.666 into 10. Now I am multiplying into 10, so the decimal point will shift towards right side. So it becomes 6.6666 recurring. Now I have two equations. One is x is equal to 0.66, other is 10x is equal to 6.66. Now I'm going to subtract both the equations. Now since 10x is equal to 6.6 is greater, so I will subtract 10x minus x. LHS will be subtracted with LHS, RHS will be subtracted with RHS. 10x minus x is equal to 6.6 recurring minus 0.6 recurring. So 10x minus x, so here simple subtraction you have to do, it will be 9x is equal to 6.6 bar minus 0.6 bar. Now this 6 bar minus 6 bar will give you 0. This will cancel 0, and 6 minus 0 will be 6. So 9x is equal to 6. Now x is equal to 6 upon 9. This 9 will come into RHS in division, and x will be equal to 2 by 3. 3 to the 6, 3 3 are 9. So I can say that x is equal to 2 by 3. And what was my x? My x was 0.66. That means 0.666 is nothing but 2 by 3 in fraction form. So this is how you convert decimal into fraction. Let us take another example. 3.171717. Now you can see 17 is repeating. There are 2 digits repeating after decimal. So we multiply it by 100. Okay. So it will be 100x is equal to, not 2, we are multiply with 100. So we will shift decimal 2 digits by right side. So it will be 317.171717 recurring. Again we'll do same step, subtracting both the equations. 100x minus x, LHS and LHS are subtracted, is equal to RHS minus RHS. 317 minus 1717 bar minus 3.17 bar recurring. Again this bar 117 bar will become 0 in subtraction. 317 minus 3 will give you 314, and 100 minus 1 is 99. X will be 314 upon 99. Now what is x? X is 3.17 recurring. So we got the answer. The decimal 3.17177 is nothing but 314 upon 99 in fraction. Next sum, 0.8666. Now this sum is different from others because in the previous sums the digits which were repeating were after the decimal. Here after the decimal only one digit is repeating, that is 666. Before that there is a digit 8 which is not repeating. So to solve this we have one extra step. The first step remains same, that let the number be x, and here we will put a bar on only 6 because only 6 is repeating in the it is in recurring. First we'll multiply it by 10, as after decimal one digit is repeating. We get 10x is equal to 8.6. Now we cannot subtract x is equal to 0.86 bar and 10x is equal to 8.6 bar, as here after decimal it is 86 bar and here after decimal it is only 6 bar. So we cannot subtract it like this. So we need to again multiply this equation, that is 10x is equal to 8.6 bar with 10, as after decimal only one digit is repeating. So again multiplying by 10 we will get 10 into 10 will be 100. 100x is equal to 8.6, it will be 86. After multiplying 10 the decimal will shift towards right by one digit. So 86.6 bar recurring. Now we can subtract equation 1 and 2 because in both the equation after decimal 6 bar is in recurring. 8.6 bar recurring, 86.6 bar recurring. So if we subtract 100x minus 10x is equal to 86.6 bar minus 8.6 bar. Again this 6 bar will be 0. 86 minus 8 will be 78. And 100 minus 10 will be 90. So 90x is equal to 78. X is equal to 78 upon 90. Now we can simplify it. 2 3s are 6, 2 9s are 18, 2 4s are 8, 2 5s are 10, and your answer is 39 upon 45. So we can say that 0.8666 recurring is nothing but 39 upon 45 in fractional form, and in decimal form it is 0.866. I hope you understood how to convert fraction into decimal and decimal into fraction. If you found this video interesting, do like, share and subscribe our channel. Thank you.